Hey, I'm going to do a little bit of polar graphing review and also going to practice writing polar curves as parametric curves, which is very easy to do so long as you know that x equals r cosine theta, y equals r sine theta, which is really something we've been doing in physics since early days of taking a vector and breaking it up into its components, right? If that vector has a magnitude of r, that's at an angle theta, then the x component is r cosine theta, and the y component is r sine theta. All right, you can make a table of values, like make a little theta r table if you want to, and pick some key values. But I'm going to try to do it a little bit more efficiently than that. So couple things to know, like if you have r equals multiple of cosine theta, r equals multiple of sine theta, those are circles. Cosine circles, cosine kind of goes with x, right? They're sitting like out here on the x-axis, and sine circles are, since sine goes with y, those are sitting up there. I'm just going to kind of think through what the values of the the cosine function are as the angles go through. So cosine of 0 is 1, which means when I'm looking in this direction at 0 radians, that's when my r is going to be equal to 8. And then when I am at, I'm just going to do the pi over 2, do those values first. When I go to pi, so then I'm going to look through these values, and I know that cosine, if you're thinking about what cosine does, cosine starts out at its max value and then it kind of dips down like this. So when I get to pi over 2 and look through all of these angles going to pi over 2, the cosine function is going to go from its max down to 0. So it's going to get back to here by the time I'm looking straight up at pi over 2. And what does it do? I know this is a circle, so I'm going to go like that. And then as I start to look past pi over 2, that's when cosine goes into negative values. So I'm looking this way, but the r's are negative, so that means the values are going to come out behind like that. And important to just remember, note that this is from 0 to pi. If you go all the way from 0 to 2 pi, that actually traces the circle a second time. For a sine circle, when I start out, the sine function starts out at 0, so when I'm looking at 0 radians this direction, my r is 0, so I'm just right there at the pole. And then as I look from 0 to pi over 2, the sine function is going to go max out, and by the time I get to pi over 2, it will be maxed out at 1, 2, 3, 4, 5, 6. So as I look at those different values, it gets bigger and bigger until it maxes out all the way at 1. And then come back around like this. By the time I get to pi over, just pi rather, then I'm back to 0 again. And again, if you go, that's from 0 to pi. If you go all the way to 2 pi, you're going to retrace that circle. All right, how about this thing? These are the types of things that make like cardioids, right? So let's see, when I'm at 0, when I look in this direction, then the cosine function is maxed out at 1, so it's going to be 1 plus 2 is 3. I think I might scale this by 2's. I'll make like that 1, 2, 3. So that's going to start here at 3. And let me just do that in all my directions. So it starts out here, and then as I go, let's see, when I get to 0 here, or get to pi over 2 rather, then that's going to be at 1, and it's going to, I don't know how perfectly I got the shape of that, but I'm really not going to stress out about that for me or for you. Then when I get past pi over 2, now I'm going to go into negative values for this, And I think I would like to know here what makes this equal to 0. This is one thing that we want to, and the same as finding the zeros of a regular y equals f of x kind of function. What are the values of theta that make r equal to 0? In other words, what direction are you going to be pointing in when it gets back to the pole? We call that the pole, not the origin, when we're in polar mode, right? So let's see, cosine of theta equals -1/2. That happens at, if you think unit circle, that's cosine of theta equals -1/2. Now, cosine is the x value, so when is the x value equal to -1/2? That happens at pi over 3 and 4 pi. Sorry, 2 pi over 3 and 4 pi over 3, right? So 2 pi over 3 is here, so that's going to come back in, and then when I get back to 0 here, when I get to pi, that is when this is the smallest value that it ever is. That's going to be -2, right? Because this will be -1. 1 minus 2 is -1. That's when I'm looking in this direction. The r is -1. So that's going to come back to here. So I'm looking this way, pi, but the r is -1. And then the rest of it just does its nice symmetrical dance back to there. And note that this is going all the way from 0 to 2 pi. Because of that offset there, we did not get that nice symmetry in 2 laps around the circle. All right, how about this? Expecting something kind of similar, right? Except this is a sine dealio here. 2 plus 4, the biggest I'm ever going to get is 6, right? So I think, well, I guess I better leave it scaled like this. So just scaled by 1s. So when sine is 0, then this one, I'm looking at in the direction 0, this is 0, and I am at 2. So I'm looking in the direction of 0 radians, that's at 2. And then by the time I get to pi over 2, when I'm looking straight up, the sine function is maxed out at 1, so that's 2 plus 4. Looking this way, 1, 2, 3, 4, 5, 6. And when, let's see, I get to pi, I'm looking in the direction of pi, it's back to 0 again, so I'm back to 2 again. And when I look in the direction of 3 pi over 2, that's this way, then this is going to be -4. So 2 minus 4 is 2. So, and then when I get back to 2 pi, then I'm going to get back to here again. So how does it trace these things? Oh, and let's also find the 0. So this is going to be sine theta is equal to -1/2. So I think unit circle, sine is the y coordinate. Where's the y coordinate equal to -1/2? That happens at, let's see, what's this? 7 pi over 6 and 11 pi over 6. So at 7 pi over 6, that's when it's going to get back to the pole. And at 11 pi over 6. Alright? So let's see if we can figure out what this does. When it's going from 0 to pi over 2, it's going up like this, and then back down like this, and then by the time we get to 7 pi over 6, it's curled back to here, and then it's got to come up to get this, back down, and like so. Right? You're really, if this is stressing you out, having to graph these things. We're not going to have to do a whole lot of polar graphing by hand, very little in fact, but I think this exercise is about getting the mode of your brain to switch into polar mode from regular function mode. Theta equals pi over 4. What? Where's the r? There is no r. It's kind of like a y equals something line. This is just saying that the angle is pi over 4 and the r, well, it could be anything, right? So where's pi over 4? That's right here. So where's the line theta equals pi over 4? It's just a straight line. It's actually equivalent to the line y equals x. How about that? How about r equals 3 secant theta? So there's different ways you can approach something like this. You can make a table, whatever. But I think that this is probably easiest if we recognize r equals 3 secant theta, that's 3 over cosine theta, and then multiply this. And r cosine theta is, that's x. So this is the line 1, 2, 3. This is the vertical line here. It is definitely harder to see that it's that if you make the table. It's much easier to do this. How do you know which thing to do? Well, I guess that's kind of tricky to figure out. But again, we're not going to do a ton of graphing of these. Just important to recognize that in polar mode you can still make straight lines. I just realized that I forgot to do the rewriting part, so I'm going to double back here. So x is equal to r cosine theta, and y is equal to r times sine theta. That's all you have to do to get it into parametric form. How about this? X equals r cosine theta, y equals r sine theta. And these things here, whether you recognize this or not, it can be helpful to recognize that this is a version of the sine double angle formula, that the sine of 2 theta is equal to 2 sine theta cosine theta. So you could turn that into 3 sine 2 theta if you wanted to. That's 4 sine 2 theta. All right. How about this one? So x is equal to r cosine theta, y equals r sine theta. Want to simplify that? Knock yourself out. Nothing really much to be gained there. X is equal to r cosine theta, y equals r. If this seems like a very silly exercise to you to write these things out, then I promise you that there's calculus reasons why we need to be able to do this that you're going to see very soon. So here, let's see how this comes out. This will be interesting. X is equal to r times the cosine of theta, but the cosine of theta is always this. Right, oops, why did I write that? So r times, and then the cosine of theta is the square root of 2 over 2. And then y is equal to r times sine theta, and the sine of that is also the square root of 2 over 2. So what do you get from this? Well, you might recognize, wait a minute, this is equal to that. So if you put those together, you get x equals y. That's the line y equals x. Here, we would do x is equal to r cosine theta, and y equals r sine theta, and look at what that does for us right there. That's 1 over cosine, and this is cosine, so that just turns into x equals 3. And then the y is equal to 3 times the tangent of theta, and of course that just ends up giving us any y value that we want, while x is always 3. All right, catch up to myself here. How about this? What does that do? I'm a little bit less familiar with what happens when we square that, so let's think through what happens when we do this. Definitely, since we're squaring all those cosine values, whatever happens here, the same thing is just going to go backwards through the same values here. So if I start with 0, the cosine of 0 is 1. So when I'm looking in this direction, 1, 2, 3, 4, and then get to there, and then cosine squared of theta. So when I get to here, when I get to looking straight up at pi over 2, then I have a cosine value of 0. So that's going to go back to there. And then as I go past and start looking here, I'm going to get those same values repeated again until I get to pi. The cosine of pi is -1, but this is cosine squared, so that's going to get me 1, 2, 3, 4, 5. It's going to get me out to here. Oops, that was 5, just to 4. Like that. And then as I go through these negative ones, I'm going to get those same values again, and then I'm going to get the same values again. Getting back to there. So that gives me a little, what is this called, a lemniscate, I think, and like an infinity sign. For our parametric, that'd be x equals r cosine theta, and y equals r sine theta. Okay, and last one here, if you recognize that you could multiply that up there, like, oh, that's r sine theta is equal to 5, and that's just y. So 1, 2, 3, 4, 5. This is just the line y equals 5. And maybe we can see that play out when we put it in parametric form. We have x is equal to r cosine theta, and y equals r sine theta. So there's the y equals 5. And then this is the cotangent function. The cotangent function can take on any value. So we get everything. There you go.